Hello everybody, welcome to day 2 for credit 7, talking about exponential growth. Okay, so here's a tree of exponential growth. So we start with one person and then he pays it forward to 3 more people. So now these represent the people. So the points represent the people and the lines represent the paying it forward to that person. So in step 1 we have one person, and step 0 maybe. Step 0 we have one person. In step 1 we have 3 and then 9 and then 27 and so on. So you're going to put that into a table of values. You don't have to draw out the complete tree, but um, you can see the pattern here that each time you are multiplying by 3, right? So you would multiply 27 times 3 and get your next step right there. Then you're going to go ahead and plot this on this graph. Now, I think that it's going to shoot way up. I don't even think 100 should be the right number. But anyway, you can fill this out and decide, do you want to go up by 100 each time? So this might start out like really low with at step 1 it was 3, and at step 2 it was 9, so pretty close to 0 there, closer to 0 than it is to 100. And then we're at 27, so about a quarter of the way to 100. But you might think that this is looking silly that I'm putting this low, but I can pretty much guarantee you that this number is going to shoot up and get really high really quick. So just multiplying 27 times 3, you're already over 100 at, what is it, 27 times 4, 20, no, you're not over 100 yet. Okay, so you're getting close to 100, and then after that you're going to be 3 times that. So you're going to shoot up really fast, and this might not even be the right scale. I might need to go to 1,000 or something like that. So go ahead and fill out that table and that graph, and then answer these questions. And now you're going to do your own with, if we change it, instead of 3 people, it was only 2 other people that were helped. Okay, and then make your tree graph, do a table of values and a graph for it. Okay, and then answer those questions. How long does it take to get to 25,000? That might be in your table, it might not, I'm not sure, but you might have to extend it a little bit. Then you're going to start writing the rules for exponents. So you saw that in each step you're multiplying by 3. So whatever step you're at, that's how many times you're multiplying by 3. So you can write the rule for finding the next pattern, the next number in the pattern for each one. So write that down in there. How do the numbers and calculations indicated in the rules express the patterns of change in tables for the stage, comma, number of good deeds data? Okay, so that would just be, kind of putting this into words. What are you doing for comparing the stage to the number of good deeds? Okay, and then write a rule for when there are four other new people. So what if there were 4? How would that rule change? And or the pattern of change. Okay, what pattern of change would you expect to see in the table of stage, comma, number of good deeds data for this pay it forward process? So kind of explain that using this information. And then here they would give you some options. So what do you think the formula would look like for this rule that you've come up with? Okay, and are any of these rules good at predicting the number of in deeds correctly? Okay, how do you know? And it's just kind of extending that question. So using that formula that you've come up with, answer these questions here. So then they're going to check your understanding, and extend this to another real world problem of bacteria splitting, right? So in step 1, you have 2. In step 2, these 2 are going to split, right? So now you have 4. So what is the process that's happening here? So each time you are doing what, and you might compare how things are growing. Go ahead and answer those questions. And then you're going to watch this video on calculating exponential functions and answer those questions. Now we get into this next process where they give you the 0 point, right? So at this point, at 0 time, there are 25 bacteria. And then at time 1, there are 50 bacteria. So if it's growing exponentially, you want to compare how is this multiplying, right? What are you multiplying by to get the next one? That's the hint. So it's going to be you're starting with 25. It's going to be times whatever you're multiplying by to some power. Okay, so this is the new form that you're going to be talking about. Okay, because each time you're going to multiply what the new population is and double it, right? And then answer these questions. Okay, so you can use a scientific calculator or Google and just try doing this 2 to the 0 power. And if you want to enter it into Google, I think you do this little up arrow, which is Shift 6, and then put 0. If you put that into Google, see what you get, and try that on all those. And you could even put it into Algebra, and it will give you an answer too. So for any positive value b, so try to make a conjecture about this. And b cannot be equal to 0. It needs to be a positive value. 0 is actually not positive or negative. It's its own thing. But any positive value of b. Okay, and then you'll make a chart for these. So when x is equal to 0, so 2 to the 0, you get something times 5. You put that answer in there, and then multiply by 2 each time. That's what's going to come out. Okay, and should be able to answer these questions. Now we get into a little bit of what happens when we use the negative numbers. So maybe test that out on your calculator or GeoGebra. So putting in a negative exponent, what does that do? We learned that from our rules last time. So it makes it go down in the denominator, so it turns into 1/2, right? So that's just a little hint for you. And go ahead and answer those and fill out your notebook. And that's it for today.